Okay, so number 9. Right here. Okay, so number 9, the area of a circle is decreasing at a rate of 135 square feet per second. At the time the area of the circle is 9 pi, what is the rate of change of the circumference of the area? So it's a circle. What's different? Or what do you notice about it? Just reading those first 2 sentences.
It's a 9 pi.
Okay. They're giving us area, right? They've done that before, right? They've given us things. But there's a difference here. What's the difference? Could you catch it?
It's not a sphere.
It's just a different shape, right? It's a different shape. Besides being a different shape, it is a different shape.
Instead of the area?
Kinda, you're getting there. Something about that.
The rate of change of the circumference instead of the rate of change.
They talk about circumference, but then they give us what? Do they talk? They talk about. They want. The question is, what is the circumference? Rate of change of circumference, right? But do they give us anything? What do they give us? What's the given related to? The area. Circumference and area are 2 different things. They're not the same. They both involve a circle, but circumference is how far would it be if I walked all the way across, all the way around the track there. That's circumference. Area is how much stuff, how much grass can fit in the middle. Right? How much grass can fit on the inside of the track? That's the difference between them. They both involve a circle, even though that's not a circle. It's not a very good analogy, but so we have a circle. Okay, so I got a circle. Again, surface area is how far is it if I were to start here and I were to walk all the way around? How far would I have walked? That's circumference. Area is how much paint would I need so if I painted that gray like it is right there, how much paint would I need?
9
Right?
pi?
9 pi, right? They tell us that part. Okay? So they're 2 different things. When that happens, you got to use step 4. Okay? Okay, so let's write the given. What is the given? So the area, circles have radii. Okay? Okay, so what do we know about that circle? What is everything that we know?
The rate of change for the area, dA over dt, is 135
Perfect.
feet per second.
The rate of change of the area, so the area is changing. So we're going to write dA over dt.
Negative 135.
It's decreasing at 135, so it's going to be negative 135 square feet, so feet squared per second. Good. What is another thing that we know?
The area is 9 pi.
The area of that circle is 9 pi. Area is feet squared because it's quantity squared. Do we know anything else about that circle? Is there any other information that they've given us that we should write down?
We need to find the rate of change of the circle.
Do we know this? Do we know that? No. So that's not the given part. Anything that's given that we know. I know that the area is decreasing at 135 feet squared per second, and I know that the area is 9 pi. Do I know anything else? No. Okay? That's step 1. Step 2. What do I need to know? If I were to solve this question, what do I need to know?
dC over dt.
There you go. The rate of change of the circumference. So d capital C over dt. Don't know that guy. If I had that guy, I'd be okay. Okay, step 3. So go to your formula list. Go to your formula list. What is a formula that involves all of these guys.
2 pi r.
So we have two formulas for circle. Which one would best answer the question?
2 pi r.
Well, what's the question?
What's the circumference?
Talks about circumference, right? So isn't that the one we want to pick? The one that has a circumference? So let's pick the circumference one. The circumference one is,
Shouldn't we use both?
we're going to have to, yeah. The circumference is 2 pi r, right? That's the only way I'm going to get dc over dt is by using that formula there. So I'm going to come back. I kind of gave you I kind of cheated a little bit because I told you we were going to use step 4, but we're going to kind of skip it for right now. Because if you were doing this problem without me telling you we would do step 4, you would probably not do step 4. So let's do it that way. So what would be the next step after that? No, before that, find the derivative, right? Find the derivative, yep. Find the derivative of the formula that we got. Okay, so what's the derivative of c?
2 pi dr over dt.
Well, c, what's the derivative of c first? Let's do c.
dc over dt.
dc over dt. 2 pi r, how do I find the derivative of 2 pi r? It's easier than you think.
Use the power rule.
No. Yeah, just the power rule, right? Just the power rule, not the product rule, right? This guy has a power of 1. So I move this guy, multiply. You get 2. How many r to what power now?
dr over dt.
No, well, r to what power?
Oh,
0. So there is no r left, right? And then dr over dt, yeah. And then dr over dt. Okay. And then plug in, right? We don't know dc over dt. That makes sense. That's the question. If I knew that, I wouldn't do all this. I would just answer the question. 2 times pi times dr over dt. What is dr over dt? No clue. No clue. When that happens, that's when you have to use step 4. You have to use step 4. I need another equation, another formula to help fill in that missing piece.
area equals pi times radius.
So the only other one that has r in it for a circle is area. So I'm going to have to pause. Step 4 is really a step. It's kind of like a side step. It's a pause. We're pausing what we're doing in the question. Over here is what we're doing in the question. But I can't go any further because I don't have dr dt. So what I'm going to do here is I'm going to use area. That's the other formula for circle. Okay. Find the derivative of that guy. dA over dt equals, and then how do I find the derivative of the other side? Power rule, so it'd be 2 pi r dr over dt, right? Plug in what I know. What is dA over dt? Do I know that?
Yeah.
I do, right? It was negative 135. It's on my list. It's right there. It's on my list. What is r?
We don't know.
We don't know, but can I figure it out?
Yeah.
How do I figure out what r is? R is actually very easy to figure out. How do I figure out r? How do I figure out?
Area by pi.
You think you're there, but make it make more sense.
You solve for r using the area formula.
Yeah, use the area formula. I know what a is, right? Pi, is pi a variable? R is the only variable. If you only have one variable, you can solve for it. So 9 pi equals pi times r squared. Solve for r. How do I solve for r?
Divide both sides by pi.
Divide by both sides by pi first, right? What is 9 pi divided by pi?
Pot 9.
Just positive 9, because pi divided by pi is just 1. What is r equal to?
3.
So I did know r. Be 3 feet. So I'm going to plug in 3 here. dr over dt I don't know. That's what I'm trying to figure out, so I can go plug it in over there to my problem. Okay. So we get negative 135 equals 6 pi times dr over dt. How do I solve for dr over dt?
Divide both sides by 6 pi.
Divide by what you don't want. Yeah, divide by what you don't want. I don't want 6 pi. I want dr over dt. Divide by 6 pi. So I get negative 135 over 6 pi equals dr over dt. That's what I wanted to solve the problem. So now I can put negative 135 over 6 pi up here. So I get 2 pi over 1, I should say, over negative 135 over 6 pi. Pi's cancel out. You can divide this by 2. You can divide this by 2. You get negative 135 over 2, which is the same as negative, wait. Oh, sorry. That would not be, that would be 3, sorry. I put 2, it shows.
67.5.
No, it's actually going to be more than that. It's going to be negative 45. dc over dt. And since it's circumference is a measurement. It's not area, it's distance. So, but it's a rate, so it's going to be feet per second.
You going to square it or cube it?
No, I wouldn't square it because it's not an area. Circumference is not an area, it's a length, right? If I walk around a circle, that's just a length. And it's per second because it's a rate. Okay? That's the difference. This part here, the second formula we needed, that's the difference. That's step 4. That's what step 4 is. Do we need to use this all the time? No. No, not all the time. Sometimes yes, sometimes no. It's when you're talking about 2 different things. So when you're reading, read number 10. Look at number 10 right now. Read example number 10. I don't think it's labeled right. It should be number 10. I don't know why it's number 9, but look at the next problem. Are we going to have a situation like we did on the last problem?
Yes.
And why? Yes, we are. And why? What's the giveaway that it's...
Going from volume to surface area?
We're talking about volume and surface area. When you're talking about 2 formulas on your list, we're going to need to use both of them. Okay? All right. Okay, so cube. Cube. Think of a die. Okay? That's a cube. A die is a cube. So let's draw a picture first. Best you can. Best you can. Okay? So it's got a length, it's got a width, it's got a height. Okay? We'll call the length, we'll call this side x, we'll call this side y, and then we'll call this side z. Okay? So we'll call the height or the length or the width, whatever you want to call it, we'll call this y. The length or the width, we'll call this d or x, and then we'll call this z. Okay? All right, so what do we know about it?
That the rate of the volume is increasing at 88 cubic meters per second.
The volume of this cube is increasing. So how do we write that on our list?
dV over dt.
There you go, yep. dV over dt equals, keep going.
88 meters cubed per second.
There you go. Cubed, oops, not c cubed, meters cubed per second. So the volume's getting bigger. Every second, it's getting 88 cubic meters bigger. Okay? What else do we know?
I don't know if that's either, I think that's z that we know.
So yeah, at the instant, so here's the thing. What's special about a cube?
It has 6 sides.
6 sides, but what's special about it though? Because there's other things with 6 sides though, right?
Doesn't have a top or a bottom.
They're all equal, right? Because this box here has 6 sides as well, but this is rectangular, right? This is rectangular. A cube is square-based, right? So every side is the same, right? Every side is the same. X, Y, and Z are all the same. So if they're all the same, I'm not going to call them X, Y, and Z because that'd be a little confusing. I'm going to call them all X. Because they're all the same. So at the instant when the side length, so when X is 2 meters, what is the rate of change of surface area? Do I know anything? Is there any more given that I haven't written down? I always ask that question because this is what I see. I see students go into the question before they've written down all the given. And then they get to the problem and they're like, you have to have a complete list of given. So I always ask the question, is there any more given? Sometimes the answer is yes, sometimes the answer is no. But is there any more given on that? Nope. Okay, we're done. But always ask yourself that question. Don't just go on to the next step. You got to finish your step before the step previous before you go on. Okay, so now what is the question asking?
dSA over dt.
There you go. It's asking for surface area. So dSA over dt. It's asking for the rate of change for surface area. Which formula should I use for this question?
Both.
Well, which one should I use first?
The volume cube.
Not the volume. Why,
SA,
why should I use, what's SA?
because we need to find
Surface
SA.
area.
No, what is SA though?
Surface area.
Yeah, don't say SA, say what it is, surface area, right? Why should I use surface area and not the volume?
We need to
know what
find
X
it.
is.
No. Why should I go surface area over here first? Because that's the question, right? Yeah, that's the question. Right? So I use the formula. That's the question. I'm not going to use the other one unless I absolutely positively need to. Okay? Derivative. dSA over dt equals 12x dx over dt. D surface area over dt, I don't have. That's what I'm trying to find. So it makes sense I don't have it. 12x dx over dt. Do I know what x is?
Yes?
I do. X is 2. Do I know what dx over dt is?
No?
No, I don't. So I have to stop there. When you get to a point like that, that's when you have to bring in the other formula. The other formula is volume. The other formula is volume equals s or x cubed, side cubed. Okay. Derivative of that plug it in. dv over dt, I know, 88. 3x squared, I know what x is. I don't know what dx over dt is, but that's my only variable left. So what is dx over dt going to be? I'm running out of space here, but what will it be? What will dx over dt be?
88 over 12?
Yeah, reduce it. Reduce as far as you can go.
22 over 3?
22 over 3, which is actually 8. 22 over 3. Sorry, I thought you said 24 over 3. 22 over 3. Yep, that's what I got. Let me go back to my question. Let me go back to this guy. So 22 over 3 is going to go back to there. 22 over 3. So 12 times 2 is 24. 24 over 1, you can divide them both by 3. And you get 176.
Meters squared, meters cubed per second?
So it's an area, surface area, right? So area is always squared. So it's going to be meters squared per second because it's a rate as well. Yep. That's the only other one. The hard part about this is the shape. That's the hardest part. They change the shape every time. Sometimes they use a square, sometimes they use a cube, sometimes they use a rectangle, sometimes they use a triangle, sometimes they use different shapes, but the shape is meaningless. The shape is meaningless because you have the formulas already. Okay? Okay, so I want you to do the last question, number 11. I want you to do the number 11 right now on your own. Okay, all right, so volume of a sphere, so we got a sphere. Okay, so volume of a sphere is decreasing at a constant rate of 131. All right, so the volume is decreasing, so dV over dt equals negative 131 feet cubed per second. Okay. At the instant when the radius is 2 feet,
It's asking. Yeah, you read that.
what is the rate of change of the surface area? Okay. I'm not going to draw a picture of you guys, we already have one in our notes. Okay. Yep. So they're asking about surface area. So surface area is where I'm going to start. That's the 4 pi r squared. Okay. So we got 4, so we got S. They use S, I use SA. It's the same thing. You can use S if you want. I just, I use SA, but whatever. If you guys want to use S, it's fine. Derivative, dSA over dt equals, again, we only have one variable on the right, and that's r. Pi is not a variable. So we got 8 pi r dr over dt. We don't know dSA over dt. 8 pi, we know r is 2, and we don't know dr over dt. That's when we got to pause and use the other formula, which is volume. Okay, because that one does have an r. Okay. Where am I? It's in the middle. There we go. Yeah, I'm just making sure I did it right. Yeah, cubed, yeah. Okay, again, dv over dt equals, yeah, it's going to be 3 because it's 3 times 4/3, right? R squared dr over dt. Okay. dv over dt is negative 131. These just become 1, so it's 4 pi r squared, 2 squared dr over dt. So it's negative 131 equals 2 squared, 16 pi. So you would get dr over dt equals negative 131 over 16 pi. That's what we're going to move back to the missing part, the missing thing that we didn't know. Negative 131 over 16 pi. So we got 8 times 2 is 16 pi times negative 131 over 16 pi. 16 pi's cancel out, yeah. You can change this to over 1. 16 pi divided by 16 pi makes positive 1. So you're left with negative 131, and since it's area, it's going to be feet squared, and it's a rate, so you're done.
Mr. Flores,
Yes.
isn't that the same exact thing as the volume? Except it's squared?
Yeah. What are you talking about? The units?
Not that the units, I'm saying like they're both negative 131 feet
Oh,
per
yeah.
second.
Yeah, you're right, yeah. So the surface area is decreasing at the same rate that the volume is. Yeah.
Is that always going to be the case?
That's a good question. I have no idea. You're the first person who's ever mentioned that. That would be a good,
'Cause that's
yeah, does it just work for a sphere? Is it always going to work for a sphere? Is it always going to, yeah, that's a great question. I don't know the answer to that one, yeah. Yeah, because it is, yeah, you're right. Because the volume is decreasing at a rate of 131 and the surface area is decreasing at the same rate. Is that always going to happen? Yeah, I don't know. I can't tell you, but yeah, it's a good observation. No one's ever said that. Okay.